or at least you have paths consisting several. Sorry. So let's assume we have a path consisting of two links, and this here we have a start time, and here we have an end time. If you assume that from the start time to the end time, between start time and end time, the whole path is occupied by a traveler, this is static traffic assignment. But if you can get a result that between S and S1, between these two time points, the traveler is affecting this link, and between this time period, the traveler is affecting this link, that becomes a dynamic traffic assignment. And in our macro simulation, we can always get the exact location of a traveler at any time point. So the result of our simulation becomes a dynamic traffic assignment. So I just mentioned that the result of macro simulation is dynamic traffic assignment. But I also want to mention that the way they assign traffic, or the way they find the path in transients or VSIM, was not based on dynamic traffic assignment. They assign traffic using the shortest path, using a time-dependent shortest path. And in that time-dependent shortest path, there is a function between volume and delay. And the way they are getting volume is using the static traffic assignment. So, for example, in transient router, you only have the information of the start time and end time. And so it's naturally, they assume that from between start time and end time, the whole path is occupied. And that's the way they calculate the delay. So their delay is based on static traffic assignment. So they can only find a path using static traffic assignment. But the result of the simulation is dynamic traffic assignment. Is it clear? The way they are selecting paths is based on static traffic assignment, but the simulation result indicates dynamic traffic assignment. For dynamic traffic assignment, you have to know when the traveler is affecting which link. But the dynamic traffic assignment is very difficult to perform. I mean, it's easy to use simulation to perform dynamic traffic assignment, but it's very difficult for you to assign traffic according to the result of dynamic traffic assignment. So let's first proceed to this concept. VDF, you know VDF, right? Volume delay function. So if I give you a function, probably you should be able to know this is VDF. And what is UE? User equilibrium. And you should also know dynamic user equilibrium. Now, dynamic traffic assignment can be done by simulation. But because we cannot perform dynamic traffic assignment in an analytical way, it will be very difficult for us to reach dynamic user equilibrium mathematically. So distinguish between dynamic traffic assignment and dynamic user equilibrium. We all want to reach dynamic user equilibrium, but the only way we can assign traffic is by simulation. And this simulation is a very complex model that can hardly be mathematically formulated. And that's why we cannot optimize this travel time thing. It would be very difficult for us to get to mathematically calculate the dynamic user equilibrium. I don't know if I made this clear enough. Do you still have questions? Do you still have any question about about this. So if somebody asks you what is dynamic travel assignment, I think you have to know dynamic travel assignment means the assignment of traveler is dynamic. In dynamic travel assignment, I know when the traveler is affecting which link. In static travel assignment, I only know that between the start time and end time, this traveler is going to affect all the links on this path.
We only have a dynamic traffic simulation, but we don't really have a true dynamic traffic assignment.
The simulation is a tool for dynamic traffic assignment. The result, I mean, in the macro simulation, you are going to get exactly where the traveler is at each time interval. So it is a tool for dynamic traffic assignment.
But we don't have a real dynamic traffic assignment.
This is the simulation is done in the not in a mathematical way. I mean, we cannot present this in a mathematical model, in an aggregate model. So we can use simulation to perform dynamic traffic assignment. But if we want to formulate this as an optimization problem, it's very difficult. And we have to assume, make a lot of assumptions. So we can do time interval by time interval simulation, and the result will be a dynamic traffic assignment. But this assignment cannot be fetched. The result cannot be fetched ahead of time before you perform this assignment. What's that?
Is that because the program is kind of like guessing and checking?
Yes.
It just loads the vehicles wherever it wants to, and then says, "Oh, this is crappy," or
Right.
"This is good," or whatever.
I think you're. That's one reason.
Iterative procedure.
Yes, that's one reason. Okay, so let's go back to the definition. So, are you not clear about what dynamic traffic assignment is? So let me ask you a question. In the router tool of Transims, every time it's making a plan. And if we examine the plan file using ArcPlan tool, I'm going to find that each plan can be represented by a polyline. And this polyline has two attributes, start time and end time. And is this a static traffic assignment or dynamic traffic assignment? Static. Okay. And if we check the output of Microsoft Simulator, and we can find the snapshots. And these snapshots, we use the snapshots to create a movie. And the result, and this resulting movie is that a dynamic assignment or static assignment? Dynamic assignment. Okay, I think that's good. I won't test this in the exam because your object is very clear about it. Now, how does leasing perform dynamic traffic assignment? So now this question is very relevant to the previous discussion. Leasing claims that it can perform dynamic traffic assignment, but actually the dynamic traffic assignment is implemented by the simulation, by the vehicle movement. But before they perform a dynamic traffic assignment, they have three key things: the generalized cost, and the learning procedure, and the shortest path. I forgot if it's the shortest path, but it's in my slide, and you can easily find this. The three criteria of leasing to perform DTA. So check the slides. Now, what are three Transims feedback procedures? Should be very familiar with that. Now we come to the last lecture. What are the error checking stages? The first stage is to check the software. The second stage is to check the input, review the input. The first stage is called review software, then review input, then review animation. I want to emphasize, in the review of animation, what do? Are you going to run a model and record the animation and review it? Is that so simple? No, you first have to use a 10% volume, or less than 10%, very low demand level, to check if the vehicle, to trace the individual vehicles. Then you use a 50%, which is not very congested, and check if anywhere it's congested. And that was the reason you use low demand level. Now, what is calibration? Do you remember the last lecture? What is calibration? If in a simulation process you have network input, you have demand input, and you have some parameters, then you run the simulation model, you get the results, get the output. What's the purpose of calibration? Let me say that again. You have network input, you have demand input, you have parameters input. Then you get output. Now, what is calibration? What does calibration want to do?
We want to adjust the parameters so that the outcome of the model are consistent with real life.
Yes, you are right. So we are going to calibrate the parameters. Right. Another thing I forgot to mention in the last lecture is what is that called when we want to adjust the demand? Do you know that? That's called OD estimation. So if you think the demand files, the OD matrices, are not very accurate, and you want to modify them, this is called OD estimation. OD estimation, or origin destination estimation. So if you search for literature, use OD estimation. That's not called calibration, just to let you know. And what are the calibration stages? The first stage is called capacity calibration, in which you want to make sure the network has enough capacity. Then we have route choice calibration. We want to make sure all the routes are correctly found. Then in the last step, we have a system performance calculation, in which we want to match the volume or the turning movement or the speed of the data and the simulation result. Now it's the end of lecture, and I hope you good luck in the exam. The exam will be roughly 40 minutes, I think. If I can do it in 20 minutes, then I multiply it by 4. You should be able to do it within 80 minutes. But I think most of you are so smart that you probably will finish that in 40 minutes. So,
how many questions?
Some questions? I haven't decided, but I will make sure that I can finish it.